Okay, let's try this. Can you guys hear me? I think I fixed it. I think I have fixed the problem. So we're going to start from scratch. Well, not from scratch. We're just going to talk about everything again, just so that I can just have this single stream. All right, hold on. Sorry, guys. I'll be more prepared next time. This is experimental at best. Experimental at best. Failure at worst. Hey, even if the stream sucked, you can still use the tool when it's built. So, all right. Can you guys see everything okay? I'm gonna just talk over what we just did real quick. So we basically are gonna we're making things asynchronous. What we had to do is follow the documentation here. This is all just so that I can just keep this one stream. So just hang on for like 5 seconds while I. So here we go. Asynchronous. Basically, everything here is from a synchronous context. We've got this for loop here. This for loop is going to execute each of these synchronously. So what we've done is basically gone from this here to we import. So the first thing we did we had this. Okay, this is what everything was like. This is all synchronous code. The very first thing we did to get this running. So the problem we have is that this for loop has to wait for each order to go through, which takes time. So we're just stalling here every time. Create 10 orders, we have to wait for each one. The solution is follow this documentation. The first thing is we need to import these two things. So we're going to basically be using a different module for CCXT, and we need to import this async IO. Then we can actually make this an async function, and we can also make this, we can await this for now. So this is going to basically run this from an asynchronous context, but since this is a synchronous context, we have to use basically this async IO event loop, which will run things. It'll convert from synchronous to asynchronous, basically. So what I've done is I've changed this to be a helper function that's async. I've made this synchronous. And then when we call this from the synchronous main function, it goes into this scaled order. This async IO then runs things asynchronous. And then we can start doing all of this stuff, okay? So let's make sure this works. First thing we can do is cancel all of these orders. And then let's try and submit these. And we're getting this error because of this unclosed connector. We're not going to worry about that for now. Let's see if we can cancel orders too. So that went through. And then let's see about canceling orders. So if we go into here, we can do this cancel all. This works. And it was never awaited. It gets mad. Yeah, so because we have two different we have asynchronous and synchronous functions, we actually kind of need both if we want to call them if we want to be able to execute both synchronous and asynchronous code, we either have to make everything asynchronous and just await everything by default, or we can have two different exchange connectors. I think that's the easiest way to do it. Was never awaited. All async, yeah. So if we want to make everything async, then we can basically go into here and just make this async. This works. And then we are going to have to actually so then we just have to await everything, basically. So then we actually don't really need to have this here. So we can just do this. So if we're going to make everything asynchronous, we can rename this back here, and we can just assume that every single function here is asynchronous. And then when we go into here, we can just await this function call, I think. Works. Will it let me do that? I have no idea if this will work, actually. No, it will not. Yeah, well, let me do that. I'm gonna actually import them both, I think. That way it's just easier to use the two different versions depending on what you need. Run until complete. Oh yeah, thanks. I actually barely know what I'm doing with Python async stuff, so I'm gonna just copy what Squaw says. Yes, so what we can actually do is run this. Yes, there we go. Let's just do it here. That's fine. Boom. Boom. Okay, so now we have everything as okay, let's see if this works. Oh, and then we have two functions. We have to await here. And let's see if this works. Okay, cool. So that actually did fix it. There we go. So that we basically created everything as async. So now the whole thing is async, which makes things a little bit more confusing. So replace main. Yeah, main. Does it make a difference, Squaw? It's the same, right? I mean, it's the same. Yeah, no, I saw what you did though. So this is fine, but it does make things a little bit more confusing for lots of. Okay, we're gonna just keep going down this path for now. Okay. So the problem is though that we have to await this every time. So Squaw, what can we do here? You're in charge. Because if you don't, let me see. Never waited. Can you just leave it? Don't think you can. Not await coroutine. On. Yes, so okay, so what we need to do is run. Let me see if this works. Let's see if this works. Whoops. Hang on. What's up? You guys are watching me struggle live. Let's see if this works. I don't think it's working. Async, IO, async. So this in theory should work. Am I doing something wrong? It doesn't like that. What I'm trying to figure out is how to not await. Okay, not await async function. Let's see what they tell us to do. Okay, so it just says to create a get event loop and then create. Yes. So create task. That should do it. So basically, here, get event loop, create task, see if this works. See if this works. No, none of this is working. Interesting. So it looks like we're going to have to await that for some reason. So we can maybe put that in a... Any ideas, Squaw? Okay, I'm looking at Discord DM. Create test limit order. Yes, I see. So you're just putting all of the orders in. Oh, I see. And then you await all of them. Got it. Thank you. Okay, cool. So yeah, so Squad knows what he's doing. I barely know what I'm doing. So we're gonna put all of the order tasks into an array. Then we are going to basically create the tasks. Create task. Task. This is going in here. We'll put that orders append task. And then at the end of the for loop, we can just run all of the tasks. Wait. Dot wait orders. Should hire this guy. You can create a list of ensure futures calls. Yeah, so okay, so you know what we're gonna do, guys? This is a lot, and while it is useful, run until complete. This is gonna be a lot more. Whoops. Yes, I think that honestly, it's more work than it's worth right now. So here's what we're gonna do. We're gonna abort this and leave it in a synchronous method. It's not worth. It's just more work than it's worth. No, I think it's just too much. So let me just actually reset this. Okay, we're gonna start from scratch, keeping things synchronous. I appreciate you watching me go through all of this. Okay, let's leave it alone. It's really not worth it. Here's how long it takes to send an order. Okay, this is with all synchronous. I will post a. Here's what I'll do. I'm gonna post an asynchronous version with Squaw's help. I'll post it on the GitHub also. Okay, I'll make a branch. So if you want to figure out the difference, you can. But we're gonna keep things synchronous. Okay, sound good? And then we can, and then if you guys ever want to, so here we go. This keeps things nice and vanilla. Yes, and then if you ever want to look at the asynchronous version, I'll post it on the GitHub repo. I'll make a branch, and you're welcome to do it on your own time if that helps. Okay. Okay. Thanks for waiting. So we can still create orders, and we can still cancel all these orders. Right? We send this through. Orders queue for cancellation. That's great. You can actually see how it runs in if you actually go and place this, watch this. You should be able to see them come one by one. Whoops. You see how the orders are appearing? That isn't just FTX lag. They're not. They are actually appearing one by one because each order is being awaited, basically, because it has to send it and then wait for the response. But it doesn't take very long. It's not. I doubt it's going to impact your trading. Okay, let's do the chaser instead. Much more useful. Sound good? Sound good. Okay. Again, I haven't prepared for any of this, so we're going to just wing it, and hopefully this goes better than the async stuff, which I think it will, because the asynchronous stuff is such a pain. Ready? Ready. Okay. Let's do so we're gonna just do a limit chaser that chases from the top of the book, okay? And it keeps updating the price until it gets filled as a post only limit order. Does that make sense? So we are going to need to do the same. We're going to need the same things, the symbol. It's going to be very similar to a simple order in terms of the parameters. Okay? We need the symbol. We need the side. We need the amount. We don't need the price for now because we're going to do a top of the book limit chaser first. So all we need is symbol, side, and amount. Right? So for example, sell 0.01 BTC is all you need to say, and that means place a sell order at the very, very top of the book. So let's get no grouping here. Place a sell order right here, and then keep moving the sell order down if the price runs away from you. This is going to be interesting on FTX because FTX book moves so much. So I might have to do a little bit of like room to make it so we can actually see it work, right? But let's just go. Let's just get started. See how it goes. Okay. So the first thing we need is these params. Same thing. We're going to want this to be a post-only order, just like because that's kind of the whole point of a limit chaser is to get a fill with a maker rebate and all of that, right? So what are we going to do? Well, the first thing we need is we actually need to know what the price. We need to know what the top of the order book is. Now we could actually yeah. So this isn't going to be perfect. We're going to do sort of an easy implementation, but not a great implementation. The ideal situation would be to open up like a WebSocket connection and stream the price. But because of the overhead of that in terms of learning, I want to make this actually understandable, and then we can optimize it later. So we're going to make a simple version of everything, and then later I'll try and make an async WebSocket version too that you guys can actually look at and compare the difference. And if you want to make that work for you, you can. But for now, we're going to do this very simply. FTX has pretty generous rate limits. So yeah, you can't exactly. So we'd have to use either the paid for CCXT, or we'd have to use the actual WebSocket native implementation for the exchange, which is another great reason why we're not going to do that. So let's just use yeah. So let me get the documentation here. But basically, what we need to do. So here we go. Here's the docs. Okay. So what we want to do, let's go back. The very first thing we need to know before we place the order is what does the order book look like? I'm going to go in here. this should be able to. Okay, let's maybe we. Oh yeah, no, we can order book, right? So you could technically, you could technically use the price, just fetch the price, but you don't know how wide you don't know how wide the spread is, right? The spread could be pretty wide, so you kind of would be guessing. So if you want to make sure that you know exactly what the top of the order book is, then you need to fetch the actual order book data. That being said, if you're using a liquid market like Bitcoin, you can probably assume the spread is pretty small. But let's just do it with the order book, okay? So I'm going to copy this code. Basically, this is exactly what we want here. So let's go ahead and do this. I'm going to put this import statement at the top. Going down to here. So we, what do we want to do? No, we don't want to do this. What we want to do is, actually, let's just see what this prints. Let's just go ahead and do this, okay? Forget about the time thing. Let's go ahead and just see what we get if we simply fetch the order book, okay? So it's going to just print it out here. So we're going to go into here. We're going to go into limit chaser. We just made this function. We're going to do btc perp. We just need to pass anything in. It's not actually going to send any orders. Let's see what we get. Okay, so we get this. Let's do pprint actually. One more time. So if we actually look in here, here's what we get. We get a dictionary with asks and bids, and we get the top of the asks with the size and the top of the bids with the size, right? Cool. So what we can actually do with this is we can basically first just figure out. So the first thing we're going to do, let's get rid of this print, and let's actually save this result. So here we go. Inside of this, we have the asks and the bids. So we should be able to just grab the top of each, right? So if we go into here, we can get do top ask is going to be res the asks, and then this is an array in here. So we're going to get the 0th element of the. Actually, I guess you could post. Yeah, okay, whatever. We'll do it this way. Okay, so we get the top ask, and then we're going to get the 0th entry, which is the top, and then the actual 0th element, because it's a pair. It gives you the price and the size, and then we can do the same thing for the bid. Top bid, and then we should be able to get top bid, and then we'll print top ask. Let's see if that works. So there we go. Top bid, top ask. The bid in that exact moment. See that? We can keep printing it. Boom. 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 Cool. So now we've got the spread. We basically fetched the spread. Make sense? Makes sense. So now that we know what the spread is in that moment, we can submit an order wherever we want. So if the top bid is at 54, we could, in theory, submit an order 1 tick size above that. So we could submit an order at a sell order. So if we wanted to submit a sell order at the very top, in theory, we should be able to submit a sell order at 355, for example. I'm going to give it some room though, because I want to not have the order get filled, because we want to test to see how the order actually moves with price. So for testing, I'm going to give some room. I'm going to give an offset for the chaser order. Okay. So the next thing we're going to do is we're going to basically, I'm going to put this, I'm going to put this in a helper function actually. Let's do this, get spread, and this is going to be symbol. And this, we're going to put this code up here, okay? Because we're going to have to keep calling this, and maybe you just want to get the spread. I'm going to put this I'm going to put this just in a dictionary. So top bid, top ask, and now you can actually call this method directly from the command line, and we can use it in our limit chaser. So I can actually call this here. So I can actually call get spread, right? Get spread. Oh, I see. We actually will need to print it. Print. See how this goes. There we go. Okay. So what we can do is we're going to basically we're going to make an infinite loop, and then we're just going to keep timing out, and we're going to check the top of the book. I guess this is more of like get top of book, more of what this is. We're going to keep checking what the top of the book is and submitting the orders. Okay. So basically, here's some rough code. It's going to be something like this. While true, we are going to get the top of the book or the symbol. Of book. This. It is. Well, it's actually not L2. It's not the whole L2 book. It's just the top 100 things. Why don't we just use the price? Because it's not perfect, but it's probably better. So assuming the liquid market, okay, we're gonna finish doing it this way, and then we can think about trying to use a price. Okay, let's just see if we do this. Let's just do this first, and then we can try and use a price. But yeah, you're definitely right about the overhead. If we actually go into here and print the whole thing, though, it's not that bad. Oops. So if I print the whole order book and I go into here and I try and get the top of the book, get top DC perp, go into here, whoops. So it isn't that much data because it's only giving you the top 10 levels. So let's just stick with this for now. Okay, anyways, so we get the top of the book. Then we are going to basically, if it's a I'm gonna actually have this offset here. Let's do offset. So this is gonna be how far from the top of the book do we want the chaser order to be? Okay. Let's do offset. I'm gonna just do a big offset because I don't want the order to actually get filled right now, right? So if the side is a sell order, then we want to place it at the top of the bid plus offset. Okay, so assuming offset was tick size, then we would be placing it at the best possible entry. Hold on, I gotta sell some, buy some Bitcoin. Okay, so if it's sell, we're basically going to oh yeah, and then I think was it Squaw who was telling me to reuse my order function. Let me just try and reuse it. Well, okay, I'm just gonna do this actually, because I want to be able to pass the params in. So we are going to basically come up with a price. The price is going to be the top of the book 0, which is the bid, and then we're going to want to place that at plus offset. So this is going to be the price, and the rest of it we can just pull straight from these. So this is going to give us the symbol, the limit, side amount, and the price is what we've just calculated, basically. Okay, so this should just very, very simply, let's actually get rid of this loop and see if this works. Okay. So assuming this works, this will just place in order at the top of the book at the offset. So here we go. So if we go over to here, go over to limit chaser, we go into cell, because that's all we've implemented yet, 0.01. That in theory should, yes, we're gonna have to definitely do that. So that actually worked. So you can actually see, we go into this grouping, we've actually placed an order at $50 above the book, and it's about to get filled. I don't want to get filled. Okay, I'm gonna make it even bigger. Let's do 200 because I don't want to actually deal with orders. I'm not using a testing account. There we go. Cool. So yeah, so we're gonna have to actually see if the so I think we can get the status of an order. We can actually check the status of an order. Let me actually, I gotta cancel a few things in here. Okay. So let's actually see what we get for the response. Okay. So if we actually print the response again, go into here, what do we get? So we get this order ID. So we're gonna have to check to see if our order gets filled or not, right? Which is going to require looking at the documentation. So in order to know if this loop is done or whatever, we need to actually check if our order got filled. Let's go into here. I'm going to look for something. Let's go to trade. We're going to go into orders, see what we got. So let's actually see then, if we then fetch orders, can we actually see if that order we have, actually, I think we can pass the ID to fetch orders. So let's actually just go into here, see if there's an example anywhere. By order ID. So, let's import time. Can I just do time.sleep, I think? Sleep, we're gonna sleep for 2 seconds. This is just a test. And then we're going to call the exchange.fetch order. And then I think we can just pass the ID. Let's see if we can do that. So first, let me comment this out. What's the ID? The ID is at just response dot ID. Okay. So we're gonna save the ID. ID equals res ID. Then we're going to sleep for a second, 2 seconds, and then we're going to fetch this order and see if this works. Cool. And I'm going to print this response. Here we go. See if this works. Sleep for 2 seconds. Fetch the order. And it works. So we were able to fetch essentially the same order. We get the same response. The difference is if the order had been filled by the time, if we sleep long enough and then wait for the order to get filled, then this status here would show that the order is not filled. Status open. So so basically, let me save this in a variable too. So order status equals res. I just want to give a second. No, it's not needed to sleep. We don't need to. You don't need to sleep. This will work fine. No, you're right. That was kind of pointless. Okay, so this basically is this is the meat of this whole thing. So what we're gonna now do is let's put this back in this loop. Okay. So now we're in this loop. Okay. So the very first thing we're going to do is let's move some of these variables up here. So the order ID may change every time we have to move the order. It's going to be a new ID. So we're going to save this as none for now. What we're going to then do is go into here. So if there's no ID, then we need to basically get the response and set the ID for the order. So this means if the ID is none, that means that we have no, whoops, this needs to go up here. If the ID is none, that means that we have no order. We have not submitted an order yet. So we're going to save the ID. No, you can't edit the order. No, orders are immutable in, I think, all exchanges. I don't think. I think we're gonna cancel and send it because a lot of exchanges don't support editing orders. Maybe some do, but in order to make this work on any exchange you want, I think that we need to just cancel and resubmit the order. The truth is also a lot of exchanges don't, when you modify an order, a lot of them give you a new ID back. Although, let me see, maybe we can. Modify order, update order, where is this? For example, Binance doesn't support this. So if we want this to work on Binance, yes, Bybit does support updating the order. You're correct. Let's see what we got here. Querying orders, multiple orders, or trading. I guess negation orders. What am I missing? Hold on. Yeah, I think keeping it general and canceling is fine. I think it's better, just in case, since not every exchange has the update method. Where's the documentation for creating an order? Why is this so hard for me to follow? Here we go, placing an order. Right, here it is. Change that, create, market buy, yes. Yeah, I think we're going to keep it. We're going to keep it generic. Yeah, we're going to keep it generic because Binance. Okay, so we're just going to cancel and create the new order, and that way you won't have any issues no matter which exchange you're using. And I think that's valuable. All right. Cool. Here we go. Sorry, I'm trading also. Okay, so we've got the ID. We saved the ID. Now, if we don't have any order, then so if we don't have an order yet, we place the order. Once we, if we yes, okay, so then we can, so now we know we have an order, okay? So if we don't have an order, we place an order. Hold on, I'm distracted by the Bitcoin. Okay, so if we don't have an order, we place an order. Then now we know we have an order, so we can assume that we have an order now. So we can actually check if the top of the book, basically if the top of the book 0 is, let me see, so if price goes down, that means that I see, so we actually need to keep track of the last price we submitted the order at too. Last price, none. I guess we can just store let's just store the whole order. Last order. That makes more sense. There we go. If not last order. Save this as last order. We don't need to do this anymore. And then we can just assume now we have the whole thing. So if the top of the book, if the top bid plus the offset is less than the last order price. Thanks. Saw that. If the top bid plus the offset is less than the price, then that means that we need to move the sell order down, right? If the top of the book plus the offset is less than the price that we submitted our last order at, that means that the last order is now too far down and we need to make a new order, right? So then what we're going to do is, first thing we're going to do is cancel this order. exchange dot, what do we got? Cancel order, yep. And then we should be able to just submit the ID, right? Yep. So let's go ahead and do last order dot ID. We cancel the last order, and then we have to make a new last order at the new price. Cool. And we can actually, yes, that's fine. We can, yeah, I think that's fine. So we basically update it, and then we just need to, yep. I see. If not last order, we need to fetch the order information because this last order is stale. So even though we have the last order, as we iterate over the loop, we won't know if the order got filled. So we need to actually fetch the order in here. If there is no last order, that means we need to create an order. Otherwise, we actually need to fetch the order. Remember this code down here? Else last order equals, we need to refetch the order because it may be different now. What if the order was filled, right? So if there's no order, we create one. But if we do have an order, then we need to check if it was filled, right? So now we have the order again. Remember this status here? So if we can just put this outside of the loop now too. If last order status is not open, I guess it's probably filled, right? I'm going to assume it's filled. Actually, let's just say if the last order status is filled, then it's done. We can just return. Otherwise, we have to see if the order needs to be moved. If it needs to be moved, we move it. Otherwise, we leave it alone, and then we can sleep. Open, closed, canceled. Is that okay? Not filled. For the docs, thank you very much. I like Squaw. I've got my personal assistant here. This is great. Cool. And now we can sleep. Sleep. Let's do, for now, let's do 5 seconds. I don't know what the rate limit is for each exchange, but I'm going to assume that this will work. 5 seconds is probably not too bad, right? So let's give this a shot. +1 for Squaw. I know, got to mod that guy. Let's give this a shot. Sound good? So this is still only supporting cell side. Need to account for partial fills. That's a very good point. You need to account for partial. So let me see that. Let's go back to the docs and let's look at this. So where's the let's see, closed. You could also fetch closed orders. Yes. So does closed assume that the order is entirely filled? I'm assuming it does, right? Qua? Order filled to see quantity filled. Yes. So you know what we can do? Yeah, the video is saved. Don't worry. So here's what we can do. Let's just assume this code works like the way we think it works. I think filled. I think you're right that filled should. Go into here. Let's look at what does the order object look like? Does it give me a schema anywhere? Order structure. Okay. Here we go. This is what we want. Yes. Filled, the amount filled in the base currency. Yes, Squaw is correct. Perfect. Status is open, closed, or canceled. Closed assumes that the entire order is filled, I'm assuming. So here's what we'll do. Okay? Here's what we'll do. We're going to basically go into here. We're going to have a remaining. Let's do. We'll have remaining quantity or remaining amount is going to start out as the amount. Cool. Now we just need to send these orders with the remaining amount. And what we can do is update the remaining amount every time we fetch the order. We go into here. Let me think. Yeah, remaining is fine. I'm trying to think. If we fetch the same order again, let's say we fetch the same order, right? What if we get multiple orders partially filled? Right? So this can get a little bit confusing. So in theory, you could have a. Oh, you mean there's also orders remaining? Oh, okay. Oh, that actually is great. I see. The remaining amount to be filled. Brilliant. But actually leaving that as remaining is fine too. So I think we can just then go ahead and fetch this, and then we can set the remaining to equal last order remaining. Should be fine. So this will account for partial fills. So now we can actually send the amount every time we get a partial fill on this chaser order, which is a pretty big edge case, but in theory, it can happen. We'll be basically counting that as we'll be updating the size for the future orders to reflect the fact that we've got partial fills. Makes sense. Let's go ahead and send this then. See how this works. Interestingly, price is moving. No, it should be fine. Let's see if this works. Cancel these orders too. Distracting. Okay. So let's see what we got here. Here we go. We have an order. Size 1 at price 38,036. And what's the last trade? What does the book look like? Go into here. You could get filled between fetch order and cancel order. I see. You could get filled, you're right. So we fetched the order, right, I see. We could have gotten some fill before we cancel the order. I see, yes. I wonder actually, so let me cancel this. We're gonna do keyboard interrupt. Get rid of this order. Do we get back the order here? Yes, I see what you're saying. Order equals, let's see if does this give me back an order? It might. Order queued for cancellation. No, it does not. So I see. So what I need to do, I basically have to fetch the order again afterwards, don't I? Yeah, it doesn't. It just returns order. That's a great catch, cash flow. You're totally right. I don't think there's any safe way to do it other than to fetch the order again, because of what Cash was saying. You basically are going to have to fetch the canceled order. Since the exchange doesn't give you back the order object, basically you're going to have to fetch it again on cancellation. And then update the quantity, the remaining. I should code live with people all the time. This is great. I love having a team. Unpaid help. Okay. In theory, that should work, right? In theory? What did I do wrong? Let's go ahead and get rid of all of these. We also probably want to make the keyboard interrupt cancel the remaining orders. But we'll figure that out later. Cool. All right, so this is, so here we have the price is at 50 and 804. So if price goes down, the order should move down, right? That's the idea. So price is going down. 4, 70. You can update. So it is not updating. Oh, did I get filled short? That's funny. Okay, let's see why it's not updating. Did my screen dim for you guys? It did, didn't it? Yeah. Hold on a second. This is a bug with PyCharm. Hang tight. Don't know why it does this, but it does this. Yeah, it was updating before, right? Yeah. So let's see if we can figure out what's going on. All right. Sorry about that. Bring back on. Okay, let's try this again. So we're gonna go into here and let's figure out maybe why. Oh, we're not updating the order ID. Well, that's a problem. So it looks like it. No, we are. We're updating last order. We're fine. Okay. Let's go ahead and print these two values, and I'm gonna actually get rid of this in here too. And I'm gonna buy a little more Bitcoin. In real life. Okay. We're gonna print these two things, okay? Is there a fill or kill in FTX? There probably is, but I want to keep this generic for a lot of exchanges. So we're gonna just implement as much logic as we need to. So something's going on here. So I'm actually going to use a debugger in here. I actually have this. If I go into PyCharm, I should be able to edit this. I'm going to go into here. We're going to run. This with these parameters. So first of all, let's make sure that works. Yep, that works. Cool. We're gonna go into here. I'm gonna end that. Cancel, and now I can actually debug it. So let's just go through this. We're gonna walk through this line by line. So order equals in front of order cancel can be removed. Yes, cool, thank you. That's right. We were thinking that might. I don't want to mess up the debugger, but I'll do it in a second. So if it's not the last order, we submit the order. Great. If the last order status is closed, which it doesn't. If the top of the book, so that's fine. And then sleep for 5 seconds. 1, 2, 3, 4, 5. Cool. Here. True. So that seemed to have canceled. Did that cancel? It did. Okay. So maybe that works. Maybe I'm just going crazy. Looks like it might be working. Let's get rid of that debug point and let's just see if it's behaving. Of course, price goes up now. For some reason, I feel like we should have done the buy side because I feel like this is going to. Anyways, we can see order queued for cancellation. Let's go ahead and make the reciprocal code so that we can test the buy side. So, do you guys want to abstract this into a function, or do you want to hard code it? Your call. Hard code or abstract? I'm not sure what will be more. I'm gonna just hard code it for now, and then we can abstract it later. I think it's actually easier for people who are less experienced, probably. I think if you're actually less experienced coding, you want it in a function? All right, we can put it in a function. Okay, let's do def, make this a private function limit for helper. Yeah, it's not that bad. Let's put it in here. We're gonna need to, well, let's just copy this code, okay? So the price gonna be okay. Let's just see if we can do this. Nah, this is gonna be, it's just too confusing. Too much stuff outside the loop. I see, we can put the whole loop. Okay, fine. Then I don't think there's any. Yeah, there's no point. The better option is just to try and make this the if statements. No, I take it back. We're just gonna do it like this. I don't care. It's just getting too. It's just too confusing. I think it's easier like this. We want to do elif, not just else, because it's possible they could send like a poorly formatted. Like what if they send like garbage instead of buy? What if instead of sell or something, it's like junk. So let's just double check with an elif statement. So in this case, we're going to want to do the top of the ask minus the offset, because now we're buying, so we need the top ask minus the offset to get to the highest possible price. Again, this is the same thing. This is the same. And then this is also going to be flipped. We can kind of fix this up later. If wait a second, if the top of the bid minus the offset is greater than the last trade, the order price, then we need to update. Does that make sense? If the top of the if the top ask over minus the offset moved to the left by offset is still greater than the order price, then we need to cancel the order, update the remaining quantity, and place a new order. Make sense? Are we on the same page? Cool, and then we can just sleep inside this while loop. All right, let's see how this works. So now we should be able to do a buy order, which okay, cool, that worked. At least its first part of it worked. We placed the buy order at 37,970. Was that right? Why don't I update the frequency? Instead of sleeping, I don't think I'm gonna get rate limited. Let's do every 2 seconds. One I gotta get rid of. As soon as I flip it, it starts going down. This is ridiculous. Okay. Up. Up. Did it move it down? It did, didn't it? So the logic is still flipped. Oh no, it didn't. It moved it up. 9. Yes, we can do that for the side, yeah. Yes, I agree with you, Squaw. Yeah. So I know for a fact it successfully moved price up, and I think it's not moving price down. I think we may have done it. We may have done it. Did they really? Like a case statement? I didn't know they did that actually. That's cool. Um, Sweet. Cool. We have basically done it. So we've done the very basics. I think this order is going to get filled. All right, cool. So I'm gonna just cancel. Well, so let me see. So one of the things that I'd like to do is if you do a keyboard interrupt, yeah, I think you mean switch case. Check for interrupt. So okay, one of the things I'd like to do is if you keyboard interrupt this, um, uh, cancel the order. Does that make sense? So here's what we're gonna do. Here's what we're gonna do. Um, yeah, I do. I just return since there's nothing else to do. Um, oh, I see. Well, is that different than order status is zero as closed? Well, is there a reason why I can't just check that? I think this is fine. I think this is fine. Um, okay. So it looks like I think I can just do this. So let's go ahead and put this whole thing here. Um, I was gonna say just because you might have other orders, right? So so we're not gonna cancel all the orders. We're gonna specifically cancel the last order if we have it on a keyboard interrupt. Actually, how about just on any error, right? I mean, why does it need to be a keyboard interrupt? Assuming there is an error and we have to break, we probably want to cancel the order no matter what. So if there is a last order, then we're gonna want to cancel it, right? And we can get rid of this. Someone said that too. You don't need this. So this will allow us to essentially make sure that should we do a keyboard interrupt or any other error. Oh, whoopsies. Not happy. Print here. Boom. And then we can print some helper information too, which will be useful. Keyboard interrupt, order is not canceled. Why was the order not canceled? There was, I see, there was, I think it was because it was updating the order right then. So we could actually sleep here for a second. Let me make sure that was it though. Let's try this again. Actually, yeah, because the keyboard interrupt here, boom. Oh no, not. Can I just do an accept here, I guess? Maybe that's it. Oh, I had an extra order. I see. I think that was it. All right, we're good. It works. Although I do actually think, so here's the thing. I actually think you want this. You want to sleep for one second. Except exception. If last order, we do that, and then we can just raise the exception. So in theory, oh no, this is not going to work. This won't help. So there is an edge case where you keyboard interrupt while you're waiting for the response from placing the order. Not really anything you can do about it, other than try and like fetch all your orders. But we're gonna just leave it alone. This is good enough. It basically usually should not have a problem. Keyword interrupt. No, no. I guess, is a keyboard interrupt not an exception? I guess that's the problem. Keyboard interrupt is not an exception. Something, right? Because it worked before. Yeah, it doesn't look like it is. Weird. Python keyboard interrupt. Maybe it's like a... I guess I can do keyboard interrupt. Can I do multiple things? Let's see. Isn't that weird? Very strange. Let's see if this works. Let me just see if this is it. Oops. Very strange indeed. Under here, keyboard interrupt it, and it cancels it. Interrupt. No, I don't know. Well, for now, I'll just do except exception as E. Just do the same thing. It's not perfect, but it's fine. Okay. Cool. I'm just looking up to see if there's something. I guess keyboard interrupt by default doesn't count, which kind of makes sense because most of the time you don't actually want to catch a keyboard interrupt. Does that make sense? Like most of the time, a keyboard interrupt isn't what you're trying to catch. But anyways, so this more or less seems to work. I'm going to put offset in here. Let's do this. Offset equals, I'm just to do this 200 for now. Then we can get rid of this. So now we have that in there. Bum, bum, bum. Cool. Trying to think. Let's see. Am I missing anything huge? Or does this seem to be making sense to most people? Oh, one of the things is I think we need to print some stuff in here to help. So, go into here. something like that. I don't know. And in there, we can, we can glorify this a little bit more, but for the basics, this works. So we basically have built. I'll put this up here. Frequency equals 2. So this is the frequency, update frequency. So you can kind of, I'm going to put these up here so people can easily change the variables and stuff. But cool. Canceled our order. That's awesome. All right. I think that is more or less where we should leave it today. We started out trying to get this async stuff working, which was a lot more of a headache than I expected. Eventually, if I get around to it, maybe Squawk can help. He can help make it all async. It would be cool to have a simple version for learning or whatever, and then a more embellished version. But this is fully functional. There's it's not really that much latency. It's not that big of a deal. So I wouldn't stress too much. This is weird. Look at this. This is updating. How often is it updating? Is it in the time.sleep is in seconds, not milliseconds, right? Am I crazy? In seconds. Why is it updating? You have any idea why it's updating so fast? Let's keyboard interrupt this. That's kind of weird, isn't it? Let's go back to cell. I know, in a lot of languages it's in. Go through the math again. It could be a UI glitch, but I don't think it is. Okay, I have to do some technical analysis to predict which way to test. I have to look at Bitcoin and come up with a... Yes, I know it does lag. It is possible. It is just I guess it could just be a UI glitch. The next coding stream topic. I don't know. Do you guys have a vote? Oh, look at the order history. Yeah, that's smart. Um, 58, 31, 32, 33, 35. Okay, 24, 44, 31, 32, 33. That is not 1 second apart. One sec. Anyways, I actually think, I think it's fine. Let me, I'm buying real Bitcoin. Hold on. Yeah, so let's try a buy. Let's see if we can do a buy. Oh, and then the lower, right? You said. Okay. Seems to be working. I'll go over here to. I'll just put this back because I think that might have actually been part of it. You just do that. Side equals side dot lower. Again. Oopsies. What happened here? Oh, that was a leftover. Again. Interesting. Why is it not? Oh, is it? I see. I think it works. I'll do some more testing, but I think it's fine. Manually move the order to see how much time it takes to cancel and place another one. What do you mean? Oh, I see. Oh, it actually didn't like that because the order got moved. It was a different order. It's yeah. So you can actually see that FTX actually does consider it a new order when you update it, even when you update it. Because if I update this manually and then I go into here and try and actually cancel it, it gets mad because it says the order's closed. Yeah, so we can eventually get to making a simple UI. Anyways, this is good. This is good enough. I'm gonna comment this real quick. So let's go through some of these comments. Chase. Offset. Cool. Current order. Chase with amount remaining fill. Okay, so partial fills along the way. Loop to place and update order. Top of the book. Set the order price adjusted for offset. If we don't have an order yet, because we don't have an order yet, place one. Otherwise, get current order to check price. why are we doing this? Why are we doing this? We don't need this. Because this was simply done to actually check if the, this was simply done to check if the fill quantity was, this is redundant. This does the same thing as this. This was simply here to get the amount remaining. But because we realized this created a potential race condition, we moved it down here, but I didn't delete it. So this is totally redundant. Am I correct? Oh no, this was, we need to check for the status. The last order status is closed. That's why we did it. That's why. Get last order again in case it has closed. If closed, done. Burn. If the top of the book adjusted or offset if the top bid adjusted or offset is above price, we need to update order. Cancel the order. Refetch to update remaining in case of partial fills between last fetch and now. Create new order. And then I'm not gonna logic same as above but inverted. Cool. Yeah, so I'll let you guys, I mean, here's the whole point is that you can do this yourself. I mean, you can pull the code and implement anything you want. That's like one of the primary, this is one of the reasons I want to keep it simple, is because I want people to take this and then build anything they want on top of it. So you've got this starting, you know, launch board of code to work with. Yeah, so you can go to town. You can go to town on this. Right? Okay, so that's it. I'm going to end this. I will push this code to GitHub so you can have it in case you weren't writing all of this along. And I'm going to, I'll end the video here, and I'll put in the docs, or in the, yeah, Squat. I would love for you to do that. If you want to go ahead and make the whole async thing, that's awesome. Yeah, I will see about, I can add you as a contributor. Do you want to be just a contributor on the repo for the finished code, and you can create a branch that you can maintain, basically? You can do something like that. Anyways, you work and let me know. We'll talk. All right, guys. Thanks for hanging out. Good stuff. I'm gonna, yeah, I'll put in the comments the description of this video to links to all of this stuff, the links to everything. All right, that's it. Good stuff. All right, bye.